This is a video for AQA Discrete Mathematics. This is Critical Path Analysis section 1.1, where we're looking at constructing an activity network. Well, critical path analysis is something which is used very much in industry and construction industry in particular, where we're planning complex projects and trying to decide how they should be approached so that we carry them out as efficiently as possible. We need to take into account what's called the precedence of the activity, so that some activities can't be started until others have been completed. For example, if you were writing a letter to a friend, then you can't actually post the letter until the letter has been written. A silly example maybe, but it shows the idea of one activity having to be completed, or maybe several activities being completed before some of the activities can carry on. So we model the whole project by using a precedence table which shows this idea, and also converting that table into an activity network. So here, for example, is a precedence table where we're looking at activities which are to do with recording and distributing a CD. So you can see there the activities, for example, taping the performance, designing the cover, book adverts in the press. Those can all be done before anything else. They're the first things to be started. But if you think about the converting the tape to the CD, obviously you can't do that until we've actually taped the performance itself, so it can't be put onto a CD until the performance has been taped. So that the right hand column shows which activities are done before other activities. So if we look down, you'll see that F can't be done until D and E have been completed. Now these are the immediate predecessors to F, because obviously if you work back from that, D couldn't be done until A had been completed. So you'll see that we don't actually include A within the precedence for F. It's there by implication that D has to come before F, and therefore A must also be coming before F. So this right hand column shows what we call the immediate predecessors. The middle column, duration, shows us how long each of these activities is going to take. Now that might be in time, in hours, days, weeks, depending on obviously what the project is about. What we're going to do first of all is to just look at the precedence and not worry at all about any duration. So I'm going to look at a simpler example just to show how we convert this sort of table into a network. So here's a simpler example, and you can see there that we've got two activities, A and B, that can be started without delay, straight away as it were. And so at the left hand side of our diagram we would put in A and B, and then we go working to the right, showing arcs between each of these nodes where the arc represents precedence. So there'll be an arc going from A to a node that we can label C. So that's showing the first bit of precedence there. D depends on B being completed, so therefore we can show an arc going from B to D. And also E depends on B being completed, so there's an arc going from B to E. F depends on C and D, so F will be a node here with C and D arcs towards there. And G depends on E and F, so we can show that by putting in a node for G, and then here an arc coming from E and from F. And then usually we would connect that together to an end or a stop point, particularly if there's more than one node which joins onto that end. Now when it comes to showing durations, which we'll look at in a second, the boxes are generally a little bit more complicated, so that instead of just a single box showing the actual name of the activity, the box is divided in this sort of fashion, where the activity is at the top. We then have 3 boxes underneath, the middle of which will show the duration. So for example, if A had a duration of 10, then that's how we would indicate the node which is representing that activity. The other 2 boxes we'll deal with in a later video. So for now though, we're just going to take this as being the title of the activity. So this is the activity A, or activity name, and then the middle box is the duration of that activity. So here's going back to the example about the CD being recorded, and so we're going to turn this into a network. So you'll see first of all that we've got the first 3 activities A, B and C at the start, so we can put those onto our diagram with their activities. The next part is D, and that has a precedence of A leading into it, so we'll have an arc going from A to D, and then the next one down, an arc going from B to E, and then F depends on D and E, so arcs coming from D and E into F. Once we've got F, we can then follow on with G and H. I depends on G, so there's I, and J depends on C and H, so from C and H we've got arcs going to J. That's everything now on our diagram, and therefore join those together with an end node. Now sometimes when you first attempt a diagram, then it will have lines crossing all over the place. The idea is to try and make your diagram so that there aren't any crossing points, so you may need to do a sort of a draft of it and then adjust it to try and make it look neat. It doesn't matter, you don't have to have alphabetical order or anything like that. It's just a case of making sure that the precedence is shown by the arc between 2 nodes, and say that the middle box is the duration of the activity. Well, that completes this video on the constructing the activity network. In the next video we'll be looking at how we then go ahead and analyze that network.